Hey, welcome to Cat Academy. My name is Akil Smith, and in this video, I will show you how to implement a JK flip-flop using the software application logisim. Before we get started, please note that the JK flip-flop has two inputs, which are labeled as J and K. In the previous videos, which shows the implementation of the D and T flip-flop, you should have noticed that they only have one input. Before I started recording, I placed the items I would need to build a JK flip-flop on the canvas. In the top right hand corner of the canvas, we have the JK flip-flop inputs with their Boolean equations that my colleague Asha got from the corner mapping. Also in the top right hand corner, we have the algebraic functions for the AND gate and OR gate. And please note that my colleague Kiara used Q2, Q1, and Q0 when she was doing the state tables. But if you look in the bottom left hand corner on the canvas, we'll be using A to represent Q2, B to represent Q1, and C to represent Q0. Now let us use the Boolean equations for the JK inputs to complete our JK flip-flop circuit. Now let's begin, starting with the first JK flip-flop on the screen labeled as A. So remember that I said earlier that the JK flip-flop has two inputs, J and K. So JA and KA will be the inputs for this flip-flop. So let's do JA first. JA is equals to BC. This can be read as B and C. So we already have our AND gate here. So now I'm going to look for B and connect it to the gate. Then I'll look for C and connect it to that same gate. Now I'll connect the AND gate to our flip-flop. KA is equals to B. In this case, we don't need any gates. We'll just look for B and draw a wire straight from B into the flip-flop. And that flip-flop is completing. Next, we have JB and KB, and those will be the input for the flip-flop labeled as B. Let's start with JB. JB is equals to not A plus not C. This can be read as not A or not C. So I already have my OR gate on the canvas. So we're going to look for not A and connect it to the OR gate, and then we'll look for not C and connect it to the OR gate as well. Now we're going to connect that to the flip-flop. Now let's do KB. KB is equals to not A plus not C. This can be read as not A or not C. So we look for not A, connect it to the OR gate, and look for not C and connect it to the same OR gate. Now we're going to connect that OR gate to our flip-flop. And that's it for the flip-flop that is labeled B. Finally, we have JC and KC, and those will be the inputs for the flip-flop labeled C. So let's start with JC. JC is equals to not A, B plus A not B. This can be read as not A and B or A and not B. Let's begin with not A, B. So now for the first AND gate that we have on the canvas here, we'll look for not A and connect it to the gate, then we'll look for B and connect it to the gate as well. For the second AND gate, we'll look for A and not B and connect those to the gate. Now we're going to connect both AND gates to the OR gate. Then we're going to connect the OR gate to the flip-flop. Last but not least, we have KC, and KC is equals to A. So we just look for A and connect it straight into the flip-flop. And that's it for our circuit. Now I'm going to press Ctrl K on my keyboard to show you how the circuit works. Thanks for watching.